Hey guys, my name is Ashish, and I've started the series for system design interview rounds. And in this particular series, uh, I'll be talking about all the basic concepts of system design, and then even I'll put videos for different questions which are being asked in interviews in the system design round. And let's start. In this particular video, I'll be, as you can see on the screen, that we're going to see that what is the introduction of system design and what is the roadmap for system design. Like, what do we need to study before solving any question? Like, what are the basic concepts? And we'll be talking about both high-level system designs roadmap and low-level system designs roadmap in this particular video. So stay tuned and watch the full video. And let's start with the introduction of system design. Okay. So, so what exactly system design means is, as you can on screen also, but don't read, just listen it to me. Like, what happens that when you design a big system, right? There are lot and lots of component which are present. Okay. So in system design, what you do is like it's a kind of process which defines that which elements of the system and how those different components and elements of the system work together. For example, let's suppose like if you highlight these things, right? The components and elements, how they work together. Uh, so let's see that there are load balancers, there are proxy servers, there is database, there is cache, and there are servers. So how these components will define and how they'll work together is what we do in system design. Okay. And in short, if we talk, if we say that it's a kind of designing a system means creating an architecture, okay? And if you go into a low level design, so it will be more of like designing the classes, interfaces, etc. That specifies the requirements and whatever requirements have been given to you. And to start with, like there is no right and wrong answer for system design. uh, we always play with the trade-offs, like okay, so as you can use, let's suppose, SQL database, or you can use NoSQL database, right? But what are the trade-offs you have to make, like when you'll use SQL, when you'll not use NoSQL database? So it's all about the trade-offs which you deal with system design. So here you can see that our system design, whatever we study, is like divided into two parts, high level and low level. And even in the interviews, uh, it is being asked like, uh, okay, design a system for, let's suppose, Instagram. Or he will specifically mention that, okay, we are having this low level design round and you have to design classes and all. So we'll talk about both of them in details. So the system design is kind of divided into two parts. Here is one is like high level design and the other is low level design. Low level design is also called object oriented design as well. So let's talk about what is high level design for now. So high level design is nothing but that architecture, overall architecture, and which shows the entire view of your system, and it describes how components of that system fit together. So we don't go in the details of each component in high level design. So it is only like you will tell in high level design, you will only tell okay, so here is the client and here is our server, let's suppose, and here is our SQL database and what protocols we are using to communicate with servers, or is there a load balancer between, do we have cache, what kind of database are we using for recommendations, what kind of database we are using for storing the data. All those things you mention in high level system design. And what you do is you don't go into the details of that, like okay, that what are the classes you'll create and what all things. So this will be dealing with the overview architecture of your system. What is, what are the things which needed when you want to go for system design round? So what all knowledge you should have prior to that, and only on that basis you will be able to do that. So first is, obviously, we are designing a scalable distributed system, so you should be knowing that what distributed systems are. And even few companies are using monolithic architecture, but a lot of companies which are highly scalable, their product are highly scalable and all, they use microservices architecture. And you have already heard about this buzz that microservices architecture is one many industry and many companies use. So you should be well versed of services architecture as well. And then for system design, you should be knowing one theorem at first, which is CAP theorem. Like you should be aware of what consistency, availability is, and it says that you cannot have all three things: consistency, availability, and partition in one system. So you have to now choose, and that's where the trade-off comes in picture. If you are choosing consistency, you won't be able to choose availability. Okay, so what is more important for you, consistency or availability? So based on that, you'll choose like that. Okay, and then comes that you should be knowing that what do you mean by scalability and what is the performance. All those terms you should be known. You should also be knowing what are proxies, like reverse proxy, etc. So it is being heavily used even in your day-to-day work. When you might not be getting work onto this, but you should know that what is this. Okay, and then you should be well aware of load balancing and load balancers, because that's where they reroute the request. You literally don't need to understand the implementation, that how that algorithm of load balancer is working and all, but you should definitely be well versed about a couple of algorithms like round robin algorithm and other algorithms of load balancing. And what are load balancers, different type of load balancers you should be knowing, so that you can present that as per your requirement. You can tell in the interviews also that okay, so and so load balancer and so load balancing algorithm we can use in our system. So all these whatever we are studying, whatever we are seeing here, like right, cap theorem, load balancer, consistent hashing, and cache, all these videos I'll create short videos separately after this particular video in numbers, number 1, number 2, number 3, so that you can study. And then later we'll be studying few systems also, like Instagram or other systems which are there. So yeah, you should be knowing load balancing, consistent hashing, and then cache. And then you should be knowing database sharding, because obviously whenever you are designing such a big system, you will need to have store lots and lots of data. So you should be doing this. I mean, you should be understanding what is sharding all about. And then you should be aware of at least one SQL, one NoSQL database. I mean, because you should be aware that how these works and what are the differences between SQL and NoSQL databases. Then network protocols you should be understanding, like HTTP, XMPP, WebSockets, etc. WebSockets I've written separate also, right? Why some network protocols? Because you should be knowing that okay, whether HTTP is unidirectional or bidirectional, whether XMPP is bidirectional or all. So some protocols you should be using. Okay, and then comes some other concepts like long polling, web sockets, and server sent events. So all these terms you should be aware of in detail, like what is long polling. So when you'll or what are web sockets, like when you'll design a chat application, you will be needing the knowledge of these particular systems so that you can use it. Like what will you use? And these questions will be asked while designing a real life problem also in the interview, like what do we use for charting and etc. And then comes, you need to use replication. I mean, you need to understand what is replication, And what is backup? So replication and backup, you should understand that what are the difference between these two, and how can we do that, all those things. And then you should be knowing some cues, you should be aware of Kafka, and other concepts some similar to that. And then comes, I'll recommend that you should read what is the DNS system, and how does that DNS system work. DNS is nothing but a domain name server. Okay, so you should be understanding its design and how does this work, right? So I hope this you will do. So while designing a large system, let's conclude that what high level design is like. So while designing a large system, we need to consider these things, like what are different architectural pieces. You need to identify what are different components, and then you need to fix them together and see that how these components work with each other, where will be they placed and all. And then third thing is, what is the best utilization of available resources, like if you don't have, let's suppose, some resource and you have instead of that other resource, how can you best utilize it? And that said, that right trade-offs to be made. This line you should always remember, that there is no right and wrong thing when it comes to system design, unless you do some big blunder into that. But it's always like what are the trade-offs you are doing. So moving forward, and let's see that what is low level design and what all things needed to be uh, studied in low level system design. So low level system design, as I talked about, like unlike high level system design, it goes into component level design process, and which is a refinement process, more of like if you are writing, let's suppose, the code, you should be well aware of like what are the classes, what are the interface, what are enums, how those classes are related, what is the use case, what are the activities going to have, what is the flow of your system going to have. So all these things are being covered in low level design. So purpose of low level design is to give the internal logic design of actual program or code which you are going to write. So it's created based on HLD itself, but it's a component wise, like. And LLD describes, as I said, that class diagram along with the methods and relations. So it describes class diagrams along with the what all methods inside that, and what is the relation between classes and program specs. Also in LLD, we design like detailed flow charts of your that component, of how the code will go through, what will happen first, what will happen last, how the response and all will come, how will you deal with exceptions, everything. And we create activity diagrams, etc., etc., even use case diagram. And there are multiple things which you do into that. And you should always remember, better the LLD, the easier it will be to code. So designing LLD is directly proportional to the easiness of your code. If your LLD is poor, definitely your code is going to be poor, and lot of changes and all you have to make later. So always go for creating a best LLD, and if you have a better LLD, it will be cakewalk to write that code. So what knowledge, etc., is required for for to be good in LLDs. So first thing is like you should be well aware of OOPS concepts, which is there, like if we talk about this is encapsulation, etc., and inheritance, and even what is association, what is aggregation, all these terms. And you should be not only aware, also you should be good in this, because when you'll create LLD, you should be knowing that how these things work and where you can best utilize them, right? And then you should be knowing design patterns, like I'll give you an example, like observer pattern. Don't just only go with singleton pattern, okay? Like some other patterns you should be knowing: observe pattern, build a pattern, right? Factory pattern. There are more patterns also I can cover in this video, but if you need, after completing the HLD design series, I'll come onto these things and probably you can read. And then you should be knowing some UML diagrams also, like class diagram and use case, activity diagram, flow chart. All those things you should be knowing, because if you don't know these, you won't be able to, design. And schema design also is important, because sometimes when interviewer ask you to write class and all, they might ask you to design a database schema as well. So yes, you should be knowing this database schema and all. And last but not least, you should be well versed with solid principles as well. So if you are able to do all those things, I think you will be in a good situation to design a good system, whether it's a high level design or low level design. So if you want to follow me onto Instagram, Twitter, and LinkedIn, or even Discord, this is my handle at the red Thriver Ashish, and I always post like educational content on these. So yep, we'll see you in another video with a concept of either gap theorem or others. Thanks.